One of the requirements for Physics 30 is to be able to solve an analytic question. This is a question designed to test your problem solving skills as well as the use of the physics principles found on your formula sheet. The 9 of them, 10 of them that are on there. So here's an example of an analytic question, how to go about solving it. They're very difficult questions, challenging, but somewhat predictable. This is the projectile motion type problem found or looked at in Unit 2. So what we have here is an electron beam in the greens entering this region between two oppositely charged parallel plates, and the electron is at the top here near the negative plate. The plates are 0.150 meters long. The distance between them is 0.04 meters. There's electric potential over here. It's at 60 volts. And the path of these electrons just comes in right at the top here. And according to electrostatic theory, there's going to be repulsion. So what's going to happen is this is going to do that, give you a projectile motion of that electron inside the plates. And this is something that you look at in Physics 20. And so there's an expectation that you remember that stuff from Physics 20. And so if we look at what's going on here, what's happening is two types of motion. We have accelerated motion as it's going down, because what's happening right here, the initial y velocity, so your initial y velocity of that electron is equal to 0. And the question is asking you to determine the initial horizontal velocity, which is in the x direction. So what is that? That's what we're trying to solve. And so what you have to remember from projectile motion is that this horizontal velocity, if we drew a vector here, it never ever changes. So my vector arrow should be the same size all the way down. But what we have here is, as this is going towards this plate, what's happening is there's a force that's pulling in. So we have acceleration acting on it, and so your velocity gets bigger and bigger in the y direction. So, like I said, you had to use two physics principles, and so what we have is the first one is it's a balanced force, and we have no acceleration in the horizontal direction. So it's a balanced force, or we call that uniform motion. And for uniform motion, what that means is that your net force is 0, so it's balanced. There's no forces pushing or pulling this horizontally. So the equation that applies to that is this equation right here for uniform motion, which you looked at in Physics 20, Vx equals dx over t. Remember, these have to be in the same plane, and then the time that it takes to do that. So the question is asking us to find out that x velocity, the x distance that it travels is 0.15 meters, and then the time is not given in the question. We go up here, and we also have to kind of figure out, what else is going on here. Well, there's non-uniform motion acting on the particle in the y direction. The net force does not equal 0. Well, what is the forces acting on this electron? The net force is the electric force that's acting on that electron. The gravity, but the gravity is so small due to the electron's small mass that we don't include it. So then your net force is mass times acceleration equals EQ, which is a definition of electric force. And the mass times acceleration, your electric field is voltage divided by your distance for a uniform field, and then Q is the charge of the electron. So what this allows us to do, we know the mass of the electron, we know the voltage, we know the distance in the y direction, and we know the charge of an electron. So what we can do is solve for acceleration, which would be just VQ divided by MD. And so we can throw those numbers in there. We get 60 volts. The charge is the elementary charge. found on your formula sheet, 10 to the negative 19 coulombs divided by 9.11 times 10 to the negative 31 times the distance, which is 0.04. So we get an acceleration rate of 2.63 times 10 to the 14 meters per second squared. That's in the vertical direction. When we're doing projectile motion, the only thing that's common between these two sides here is time. The time it takes to go up and down is the same time it takes to go across, so that's kind of our link between those. So that's what we have to use that acceleration to find, is to find that time, and how we do that is using our kinematic equations. So I'm just going to throw that over here under the parallel plates because I'm running out of room, but one equation here is d equals VIT plus 1/2 AT squared. So you got to find a formula that has time in it, acceleration, and distance. Remember, your initial velocity in the y is 0, so we get rid of that. And your equation is d equals 1/2 AT squared. And that's distance in the y direction. So we have our y distance, we have our acceleration that we just found over here, and then we can solve for your time. So your time is 2d divided by a, all square root. And if we substitute those values, your distance is 0.04 meters, and then your acceleration is what you get in your calculator, 2.63 times 10 to the 14 meters per second squared. A little messy there. And don't forget to square root both sides, and you'll get a time that's quite small, 1.74 times 10 to the negative 8 seconds. So now that time is the same time here. So what we can do is now go up to this equation way up here. The question was asking us to find that horizontal velocity of that electron. We know the horizontal distance. Now we know the time. And so I'm just going to find Vx right here. It's dx divided by our time, which is your distance in the x direction, 0.15 meters, divided by that time of 1.74 times 10 to the negative 8 seconds, and we get a velocity which would be fairly quick velocity, not quite the speed of light, but your 8.6 times 10 to the 6 meters per second. So what we've done is use two physics principles that are found on your formula sheet: uniform motion, non-uniform motion. Separated them. We found our answer, and so that's how you do a projectile motion question.